Hello, everyone. This is Colleen Milton, and on behalf of BigPanda and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled Machine Learning in IT Operations, the Role of Transparency, Trust, and Control. Leading off the discussion today will be Nancy Gohring, who is Senior Analyst, Application and Infrastructure Performance at 451 Research. Following Nancy will be Elik Eizenberg, who is Chief Technology Officer and Co-Founder at BigPanda and the inventor of open box machine learning. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen below. We will answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download. And finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to Nancy.
Great, thank you, Colleen. I appreciate the introduction. So I'm going to talk today about what's driving interest in AI and machine learning and IT ops. And then I'm going to talk a little bit about big picture adoption of AI and machine learning based on a recent survey that we did here at 451 Research. And then I'll drill down a little bit more specifically into AI, machine learning, and IT ops, and close with a really big picture look at who's leading the pack in terms of adoption of AI and machine learning overall. So stepping back to sort of the very big picture here, I'm going to talk just for a minute about what is driving interest in AI and machine learning and IT ops. And at the heart of it, it's about a growing complexity that we're seeing in modern apps. So businesses today are adopting a host of new technologies. They're often doing that to respond to disruption in their industries. They're doing it to become more competitive, to be able to move faster. So this need for speed is actually a really big driver that we're seeing for the adoption of new technologies. Specifically containers, that's one reason that we hear a lot of organizations say that they're adopting containers, is so that they can more quickly push out updates to their applications to respond to all of these demands from customers and from the competition. But containers are only one type of new technology that we're seeing organizations embrace. So we're also commonly seeing organizations use microservices architectures. We're seeing them embrace a whole host of different languages and frameworks. So we're seeing organizations are more frequently operating in a polyglot environment than they used to. Of course, we're seeing lots of cloud adoption and all kinds of clouds. So it's not just maybe one infrastructure as a service cloud, but a lot of organizations are relying on multiple public infrastructure as a service clouds, as well as PaaS, as well as private clouds, and using those cloud services in conjunction with maybe third-party services and with legacy on-prem workloads to make up their applications. You've got public and private networks. You've got, legacy gear like mainframes. You might have a whole bunch of different database technologies. So in short, the modern app is very, very complex. It's really different than a traditional monolithic application environment. And the modern application is very often much more dynamic than those traditional applications. And this is just sort of a snapshot of, what a modern environment looks like in some of these very large web scale and leading edge types of organizations. And this gets at both complexity and also scale and dynamacy. So Google currently is launching 4 billion containers every week. Netflix, very close. PayPal, I just think this is kind of an interesting perspective. So they had 700 apps, and they moved to containers and ended up with 150,000 containers. So My point here is just to illustrate how the adoption of some new technologies like containers adds a lot of complexity, right? There's just many, many more components that make up an application, and each of these components has to be tracked, or you have to have some sort of visibility in it to understand the performance of your application. And they're also changing a lot, and each of these change events creates some piece of operations data, some telemetry that might be interesting as you're trying to figure out what's going on inside of your applications. And so to give you a better idea of just how much data these complex environments are generating, let's take a look at some really large organizations. So, and this is not just about containers, so this is overall throughout their environments. Yelp is ingesting something like 25 million data points a minute. Twitter, 4.8 billion metric writes a minute, and look at how that's increasing. That's up from 3 billion in just a year. Slack, its web servers emit 35 million metrics, and then a whole bunch of data points here from Uber. That last one I think is interesting. They said, and I got this stat in the second quarter this year, and they said that they had seen a 20% growth over the previous quarter in terms of persisted metrics. And so, these are all very large sort of web scale types of businesses. So you may be saying to yourself that you are not, you're not Twitter, you're not going to be producing or ingesting this volume of metrics. But I think these growth statistics are really interesting, and the fact that these organizations tend to have very modern, complex environments. I think it's a lesson really for everyone that is modernizing and hopefully growing, that as you modernize your application environments, as your business relies more on applications and software, you're going to begin to grow the volume of metrics that you're collecting that enables you to get insight into your environment. And that can create some challenges. So while you're collecting this growing huge volume of data, you still have these pressures to fast, right? And this is a really old quote, so a lot of you maybe have seen it, but I think it's really interesting. This is a guy, I don't think he's actually at Amazon anymore, but he's the guy who developed the recommendations engine for Amazon.com. And he said that for every 100 millisecond of delay on the site, that costs Amazon 1% in sales. And that's, I think, such a clear indication of how important speed is, in this case, in terms of response time, in terms of the way that the application or the service works. But the point here is you have this pressure for speed, and you're drowning in data about performance of your application or service, and that volume of data often makes it really difficult for you to quickly solve problems so that you can continue to offer a very performant service to your customers. And this, in a nutshell, is really the driver for this recent interest in AI and machine learning in IT ops. So if you've got this huge volume of data, humans literally can't sort through it. You can't just visually look at it and understand what's going on. You can't even just, watch individual metrics and how they're trending in order to figure out what's going on, because there's too many components that make up your application. And so I would argue that these combined, scenarios are really what's been driving this interest in employing AI and machine learning in IT ops, so that you can run really sophisticated analytics that can sort through this huge volume of data and surface what's really interesting so that you can solve problems faster. So let me just talk a little bit more broadly about AI and machine learning adoption. So we did a survey recently into AI and machine learning adoption and challenges. And just a caveat here, I just want to be clear that the survey was not specific to IT ops. So we were just generally asking respondents, we were asking IT decision makers about their organization's use of AI and machine learning. Could be anywhere. So it could be IT ops, but could be other areas of the business. But obviously their responses are very relevant in an IT ops context. So what we asked here was, what's the most significant benefit that your organization has realized from using machine learning? And you can see gaining a competitive advantage topped the list. Improving the experience for customers is number 2, and responding faster is number 3. And these are very much the types of reasons that I'm hearing from enterprises who are adopting machine learning and IT ops, right? So they're doing it so that they can drive performance of their applications, so that they can continue to be competitive, so that the customer experience is as best as it can be, and so that they can respond faster in terms of solving problems, but also pushing new capabilities that might help them better respond to opportunities and threats. So these are really the big drivers that we're seeing in terms of adoption of machine learning. But, it's not all rainbows and unicorns, right? So there's also some challenges involved with adopting and embracing machine learning. So here we ask, what's the most significant barrier to your organization to using machine learning? And as you can see, sort of far and away, the biggest barrier is skilled resources. So, and again, this would really depend on what you're doing with AI and machine learning. So certainly if you're developing it yourself, you're going to require some pretty significant skills, right? Some real data scientists. But I'm beginning to see tools, especially in IT ops, evolve to ensure that they're a little easier to use, so that you don't actually have to be a data scientist, but that you can be an experienced IT ops person or a line of business person, and you can take advantage of the machine learning technologies. So you can see there's kind of a shorter list of other barriers, but skills is really the big one that's slowing people down. And I think that vendors, particularly in IT ops, are beginning to respond to that. People recognize that that's a shortcoming, and it's a challenge that businesses are facing. So let me talk a little bit more specifically now about AI and machine learning and IT ops. So, there's been a ton of buzz around it. I'm sure everyone on this call has heard people talk about AI and machine learning and IT ops. There are indeed some real benefits to it. So the clearest ones really are speeding root cause analysis and speeding mean time to repair. So if you're able to run machine learning and AI on the IT ops data that you're collecting, you can more quickly discover the root cause of a problem. So the sophisticated analytics are being run across your IT ops data. They may be correlating the data into a single incident. So rather than being alerted about each piece of your complex application that is having a problem, it's correlating those problems together and helping you pinpoint which problem is actually the source that needs to be fixed. So that's a it's a very easy benefit, right? So it's something that is a very clear benefit to running machine learning on your IT ops data. Another benefit is being able to predict and prevent incidents from occurring. So it's interesting. This is an item that I feel like people talked about a couple years ago at the very beginning of using AI and machine learning and IT ops. And it's come a long way. So I think initially there were challenges, and it didn't necessarily do a great job at really pinpointing real potential problems. but I've seen a lot of advancements here, and some of it is along the lines of discovering anomalies, and correlating those anomalies with historical events, so that if something is trending in a direction that it trended historically before a big problem, the system can alert you that an issue may be about to happen, and you can take action to prevent it. So this is sort of the holy grail, I feel like, of AI and machine learning and IT ops. And again, it's something that I've seen come a long way from the beginning, and really offers some real utility right now. I'm beginning to see organizations take advantage of this and actually be able to prevent problems before they impact customers. And this final point here is one that I find particularly interesting. So I'm beginning to see some vendors apply machine learning and AI to data about the incident response process. And so, one thing that this can do, the very basic form is indicate the performance of the team, of the incident response team. So how long it typically takes to identify the root cause of a problem and then solve it. But there's a lot of really, I think, interesting potential here. So, for instance, you can begin to analyze this data to find if your team is responding to the same kind of event over and over, and that can actually drive changes to your technology and your IT environment that can prevent whatever issue it is that they need to respond to over and over. So it can actually drive real change in terms of your technology, and then ultimately in terms of your performance. So this is something that I'm just really seeing the beginnings of, but I think there's a lot of real value here for organizations that can use machine learning and other advanced analytics to surface insight about incident response team performance in a way that can really drive improvements in your applications. But again, it's not all, this isn't super easy across the board. So there's definitely some barriers that I'm seeing organizations face when they're trying to embrace machine learning and IT ops. So one of them is just really related to the hype around this topic, right? So everyone's talking about AI and machine learning. Most people, aren't even 100% sure exactly what it is. It feels like a big marketing thing. So I think there's a lot of uncertainty out there around the benefits to it. And I think we're beginning to really get over the hump a little bit here. So I think as enterprises begin to experiment with some of these tools and see that there are some real benefits, I think that they're beginning to sort of cut through the hype a little bit. But this is definitely something that is still an issue, right? So people are not totally clear what the benefits are. There's also this issue around internal skills related to using AI and machine learning. So, again, if you're building your own machine learning technologies from scratch, you're going to need some really sophisticated data scientists. But I've seen vendors come a long way in terms of the way that they are employing machine learning and the types of tools and controls that they're giving customers so that they can more easily take advantage of the machine learning. And you definitely don't need to have, a data science degree in order to take advantage of it. I think there's also some challenges related to running your AI and machine learning across all or most of your IT ops data. And this really gets back to, sort of a trend that I'm seeing in a lot of enterprises where the number of monitoring tools that they have is sort of spiraling out of control. And so there's this sort of a challenge around unifying that data so that you can run machine learning across a unified IT ops data set, which is really going to give you the most advantages. So, there's a number of ways that you can do this, and I think that it's a barrier. It's something that people are trying to work out and figure out, and until they do, it really is going to limit the value using AI and machine learning in IT apps. And then finally, there's concerns from end users sometimes around a lack of control over the way that AI and machine learning is applied. So, some of that is really related to visibility or a lack of visibility into what kind of algorithms are being used, what data sets they're being applied to, whether or not a certain type of algorithm is going to benefit you in terms of being applied to a certain data set. So I think there's this lack of control that some organizations are struggling with and that are making them slow down their adoption of machine learning. And so those are sort of, the real benefits that I'm seeing to using AI and machine learning to IT apps, as well as the barriers that I'm seeing. And I just want to leave you with sort of a parting shot here, and this is some figures from the survey that we did recently that very clearly indicate that tech-savvy and large businesses are really leading adoption of AI and machine learning. And I think that should be of interest to everyone because, the tech-savvy and large businesses are often successful, right? These are leading organizations, and they're the ones that are leading the charge in terms of adopting AI and machine learning. So, you can look at some of these stats. 83% is companies with more than 10,000 employees that say they'll implement machine learning in 3 years. That's compared to 61% of companies with fewer than 10,000 employees. I thought that one was interesting. The 29% stat is interesting too. So 29% of companies with more than 10,000 employees are likely to be currently deploying machine learning. That compares to only 15% of companies with fewer than 10,000 employees. So we're definitely seeing the larger and the tech-savvy businesses are the ones who are embracing machine learning and most likely getting the benefits from machine learning already. And this, again, is really generally speaking from this recent survey that we did. And so with that, I will wrap it up and hand things over to Elik.
Thank you, Nancy. Nancy talked a lot about the barriers to adapting machine learning in organizations, and she touched on the uncertainty around benefits and the lack of internal skills and most importantly, lack of control around how you apply AI and machine learning. And this is where I'm going to spend most of my time talking about those challenges and how we recommend companies to address those challenges and actually be successful when it comes to adapting AI and ML. In general, I can say that, we've spent, we've talked and worked with hundreds of organizations, IT organizations trying to adapt AI and ML. And I can classify those organizations into two types of customers or companies. One company would be the very idealistic company that can talk a lot about ML and the value that will come out of AI, and kind of thinking about how the world will look like in 15 years from today. But often those idealistic organizations are not very much able to actually take that vision and implement that in reality and actually capture the benefits that ML and AI can provide. And then there are many companies that are actually very pragmatic in their approach. And these are companies that are focused less about the vision or the promise of AI and ML and more around how can we capture the benefits in the short term and expand the benefit over time. And I'm going to talk a little bit about how I think pragmatic organizations are doing that and how I recommend other organizations to also approach this initiative of adapting AI and ML. So first, let's spend a couple of minutes just talking about what we had before AI and ML when it came to IT operations. And I think this will be familiar for many people. Rules, if you look at any kind of traditional IT operation system, you can set up many rules, sometimes hundreds of different rules saying this is a threshold or this should go together or this should be high priority, low priority. There are different kinds of settings that you can set up, but essentially it's a rule system where you say if this happens, then do this. Another approach that we've seen about 15 years ago, this started to develop around maps. It could be a CMDB, it could be some kind of other registry, but essentially you're trying to develop some kind of topology map describing your data center. So you try to input some dependencies between databases and servers and applications, or you might try to map certain infrastructure elements to business services. And the hope was that using those topology maps, you'd be able to say this host is very important because it's impacting a certain service, or these alerts coming in from various applications are all related because they are tied to the same database. So this is the maps approach. And a third, what you see many organizations actually doing is actually go ahead and develop their own code in Perl or Python or something else and try to write scripts that would automate a lot of the workflows of IT operations. And I think there's a huge benefit in all of these three approaches. It's very predictable. You know exactly what you're going to get. It's very easy to input exactly the logic that you're looking for. It's entirely under your control. But in the same time, I think most organizations I talk to would agree that these approaches have actually failed in attaining what they were hoping to get out of these approaches, especially in the last 5 to 10 years. And the main reason is that just the way infrastructure looks like has changed drastically, right? If you go back in time 20 years, you would probably see, a cluster of Java applications running on a few Solaris boxes, one Oracle database, and that's your application. Today, what do you actually see? Like Nancy mentioned, you see containers, you see clouds. Even on-prem technology now uses multiple programming languages, multiple databases, multiple application stacks. So the complexity and fragmentation of the stack is way higher. And also you see just the whole agile movement of the last 15 years. You see how environments are much more dynamic. It could be because people are deploying code more often. It could also be because people are now orchestrating servers, tens of times every hour, adding more capacity, reducing capacity, adding more new applications on a daily basis. And this is resulting in a situation where if you try to use rules or maps or scripts for this, they go out of date essentially the moment they are deployed into production. And you have to make sure that in some way you have to make sure that your rules, maps, and scripts catch up with how your system is changing over time. So the more I talk to companies, the more I see that people are being convinced today that a new approach is needed to be able to automate how they handle their IT workflows. So naturally, I think there is kind of wall-to-wall agreement today that the direction that will help us address this is machine learning and AI. And I think it's pretty clear that's the path forward. And yet, time over time, you see that machine learning initiatives fail. You see many companies saying, we tried something a couple of years ago, we tried something 3 years ago, we're still trying something, and we are still unable to see any benefit from the machine learning work. And many companies are kind of falling back into the same techniques we saw before around the rules-based systems or the maps or the scripts. Even though they have a vendor providing machine learning capabilities, they are not necessarily being able to see value out of that, which means a lot of money spent, time spent, and essentially a lack of trust within the organization towards ML technologies. I'm going to spend about 10 minutes or so just talking about why it often fails, so you can kind of anticipate ahead of time if you have an ML initiative, what kind of challenges you're going to see. And then I also talk around how you can address that and actually solve that problem. So we'll start with the number one gap, which is around being machine learning being opaque in contrast to the rules-based systems or the traditional approaches. So when you think about a machine learning or AI, normally behind the scenes, what you actually have is some kind of, it could be a neural net, for example. It could be, when we say deep learning, we mean a neural network is behind the scenes actually doing the learning. It could be more traditional machine learning in the form of some decision tree. It could be some kind of statistical model. But in the end, what actually contains the insight around machine learning are huge vectors and matrices containing numbers. What you see here on the left, for example, this is a neural net, a very simple neural net. And when you actually look at the real-world machine learning algorithms, this would be about 100 times as complex. So naturally, no human beings can actually peek into this list of numbers and dependencies and try to make sense of it and understand how the machine learning works and why it made certain decisions that it has made. And when you have this kind of opaqueness, it becomes extremely hard to agree with any results coming in from the machine learning system. And I'll give you an example. For if you see that certain events get correlated using a machine learning algorithm, right? So you see, for example, that you have some application issue tied to some slowness in your database, and you have hundreds of events being correlated together to compose just one incident correlating those events together. If you have no idea what is the dependency between those events, why they are related, why the machine learning decided that all of them are somehow related, how can you go ahead and say, okay, I'm willing to accept this decision and now work on top of that? So without being able to agree with an insight, it's very hard to actually consume it and use it in your workflows. And on top of that, because it's a black box, you actually cannot even extract insights that would help you get to action faster. So, in the case we said, the database provides some slowness. Had the algorithm actually bubbled that up and said, we saw slowness in your database, and that's why you have latency issues in your application, now you have some insight about impact, you have some insight about root cause, and that already accelerates your ability to act on top of that. But if all you see is just hundreds of events being correlated together without any visibility around why they are related, and all you can do is peek into these numbers you see on the left, then you are actually unable to extract any value from the machine learning system. Then another thing, another challenge that we hear often from our users is just the time it takes for the machine learning model to learn. Most supervised learning systems, essentially the way they learn is that the operators in your team, it could be a level 1 NOC organization, it could be level 2, level 3 responders, they essentially have to train the system over time, and they have to say, this is an important event, this is an unimportant event, these events are related, this event often escalates into another event, depending on your workflow, but in all cases you have to actually teach the system how to behave. Now, the big problem here is that it takes a long time, a lot of time for machine learning to actually gain accuracy. So even if in the first few days of teaching the system you get some initial learning, if you really want to trust the system and get to a point where it's actually valuable, where it hits high accuracy, you really need a lot of samples. And the number of samples normally is in the thousands. It's not even in the hundreds. It's in the thousands before the system can actually gain accuracy that is worthy of IT operations environments. Right? If you were ready to accept, a prediction that's 70% accurate, maybe I can say, 100 or so samples would be enough. But no one is going to make an action based on something that is 70% accurate. People expect in their IT operation system, which is tied directly to revenue, people expect at least 99%, 99.9% accuracy. And to get there, you need thousands of samples, of training samples. And for that, often takes years or at least months to educate the system around this knowledge. It requires immense discipline from your operators, so you have to enforce for everyone on your L1, L2, L3 teams to actually input their insight into the system. And all this has to happen before there's any value that can be captured from the machine learning system. And then often we also have some kind of business knowledge already existing in my environment. Maybe you already know that a certain issue in a specific firewall is often causing certain problems with a specific business service. You would like to be able to tell the system, I just know this is as a fact. I'd like to educate you immediately that from now on, every time I have an issue in my firewall, mark this as related to that business service. But because you have to train the system over time with many samples, it can take you 3-4 months until the system actually understands this very simple insight that you already have in your head. So this is a big challenge that often occurs with supervised learning in an ML environment. Number 3 is around testability. ML and AI in general introduce a certain new requirement around being able to test how the model behaves in production, because it's no longer somebody on your team that actually inputs the logic and they know that the logic makes sense. If you had a rule saying do something, how the rule is going to behave. If you write a script, during the development process, you would normally test the script and make sure that it works the way you would like it to work. When it comes to machine learning, the machine learning gets to certain insights. So it learns, it develops an insight, But are you really sure that you'd like to deploy this insight immediately into production and take the risk that you might have some unexpected downtime because of a certain insight that is wrong? Probably not, and that is why it becomes extremely important to be able to test whatever the machine learning model is learning over time. And I'll give you a quick example. Think about a system that is designed to automatically suppress events that are non-actionable. So you get alerts from your monitoring tools, and some of these events, as we all know, are very highly actionable and are important to your to the uptime of your system. And some events are more informational and are not as important. And the machine learning system that will try to classify what is critical and what is not critical is very valuable. But even though it's very valuable, if it now makes even a small mistake and accidentally suppresses an event that is actually very critical, then now you're at a point where you cannot trust the system. And what we see often in organizations is that people say, after a few, 2 or 3 mistakes, people just say, listen, I'm not going to deploy this to production anymore. I'm just going to use rules in my production because this is not testable. Which means it's extremely important to be able to take whatever the machine learning has learned and then test it based on your historical knowledge. If the machine learning gets to certain insights before you deploy it, if you had a very easy way to say, show me how that insight would have looked like based on the last 6 months of data that I have. Show me what matches it might have had in the past, and then I can confirm that it works the way I would expect it. And then you say, I'm okay with this, I'm going to deploy to production. That would have been great, but most systems actually don't have this capability. So you just gotta deploy machine learning in production and then pray that it's gonna be enough and it's gonna work tomorrow morning the way you would anticipate it to work. And we see all of these big challenges really pushing back the ability of organizations to move fast on those initiatives. We see a loss of trust. We see that even if there's one champion for machine learning and AI, we see that many other people in the organization just over time kind of develop an aversion and say, hey, we're not willing to develop this. It's just not going to work for us, and push back on that. And in general, if you don't see a benefit, right, you're not going to keep investing more time and money into the initiative. So these are very serious bottlenecks to adoption of ML. But there is an answer, right? This is not the only reality that is available, and there is actually a lot of organizations that have been very successful with the AI and ML and really have been able to upgrade their IT operations significantly thanks to AI and ML. So how do these organizations attain that? So I have 2 big high-level advice that I want to provide here. And the first and most important one is just incremental implementation, right? This sounds very basic, but it's not easy to actually implement kind of an incremental approach to adapting ML. And here I like to think often about self-driving cars. So, you have self-driving cars driving right now in a few states in America. And, some of them drive really well on highways, but when you get to the city, you never will trust this system, this car on its own. A human driver will take over when you get to the city. Or some cars will drive nice in clear weather, when it's sunny out there, but when it starts raining or gets foggy, yeah, it has to be a human person that takes over. And over time, in 3, 4, 5, 6, 7 years, perhaps people will be responsible for more and more of those workflows and use cases and scenarios and trust the system more. But it has to be an incremental approach so you can develop trust. And the diagram you see here is this is essentially what I would recommend any organization to say, hey, I'm going to adapt ML maybe in a specific environment. If you have a few lines of business, maybe say just one line of business or a couple of lines of business, this is where I'm going to start with ML. And also maybe some just certain use cases, right? You have many use cases in your operations where engineers maybe remediate issues, maybe they escalate issues, they suppress issues, they do analytics on top of data to try to understand different metrics in their business. These are different use cases. If you try to automate all of them at once using machine learning, you're going to have too many fronts in which you're fighting. But if you can limit that and say, okay, here are 2 use cases, here are 2 environments that I'm going to focus on, you're likely to be successful. And then over time, you can extend. The more you gain trust in the organization, the more you learn how to do that successfully, you can say, okay, let's expand to 3 other environments. Let's expand to 3 other use cases. And sooner or later, within about 3 years, I would say, you can get to a point where the majority of your workflows are being automated using machine learning. Now, part of the challenge in incremental implementation is that now the collaboration between humans and machines becomes so central, right? Because you have some use cases, some environments that are being handled using machine learning, and you have the other remaining use cases and the remaining environments being handled by teams and people. And then the communication between machine learning and team becomes so important, right? Without that, you just cannot do an incremental approach. And some vendors will go in and say, it's kind of an all-in proposition. You either go all-in machine learning across your organization, or you have to remain manual and based on human beings. But the reality is that you can actually have a hybrid approach and then expand the machine learning footprint over time. So what's the key for that collaboration between machine learning and teams? The key is really in three things. The way we analyzed it when we talk to our users. It's essentially around transparency. The machine learning has to be able to verbalize its insight in a way that human beings can understand very easily, and it cannot be, it cannot be huge vectors or matrices or neural nets of numbers, because no human being can process that. It has to be very simple, such that even the most junior operator on your team has to be able to understand what the machine learning is telling it and why it's made a certain decision. Secondly, there has to be a way to control the system. So there has to be a way to tell the machine learning, hey, I have this knowledge that I know is a fact. I'd like you to just take that and act upon based on that knowledge without me having to wait 6 months to train you to capture this knowledge. I just have to be able to educate you overnight immediately with a certain insight that I have. So that's kind of if transparency was around how machine learning communicates with the human beings, control is about how human beings educate back to the machine in an effective way. Instead of just supervised learning over long periods of time. And there also should be ways to constrain the machine learning. This is still around control. There should be ways to tell the machine learning, I love what you did here, but never act upon these kinds of events, or never act upon this part of your environment, or never act in specific times of days. So there has to be a way to also constrain the system. Again, it cannot be an all-in proposition where you say, I take machine learning and I have to use it everywhere. You have to be able to constrain it very easily. And lastly, it's around predictability, right? Like what we talked about, lack of testing. There has to be a way to understand how machine learning is going to behave based on your historical data. So what I'm going to do next, I'm going to go briefly and show you actual real-world examples. So I'm going to show you 3 examples of real-world usage in our product, in BigPanda, how people actually get transparency, control, and predictability using for machine learning. And this is what we call open box machine learning in BigPanda. So I'll start with an example around how you can control and modify the logic coming in from the machine learning. So in this case, what the machine learning does in BigPanda, in this case, this is a correlation pattern used to correlate different events that could be related in your environment. So the end value to your organization would normally be that instead of having to process tens, if not hundreds, of symptoms coming from different systems, environments, we essentially take all the ones that are highly related and we create just one incident out of that. And the way this happens is that the machine learning processes your historical event data and then sees patterns and says, okay, this is how an outage looks like in your environment. Whenever this application has an issue, we also know that the following queuing systems have certain event overloads or something of the sort. So we would detect an outage like this based on your historical data, and then we would create a pattern to automatically correlate any time an outage like this happens in your environment. And the way we do this, we actually suggest a pattern to the user. So we don't just push that into production immediately. We say, here's a suggestion around how these events should correlate together. And then you can go in as an administrator, you can go into the system, you can say, listen, this is amazing, you saved me now hours of work, and just push it into production. Or you can go ahead and you can say, you know what, I like this, but I'd like to modify this. I'd like to change how aggressive it is. So maybe I play with the time window and I extend the time window or relax it a little bit. Or I can add some query filter and say, only act on specific applications or specific technologies or specific clusters. I can change the monitoring tools that are taken into account here. And then I can just choose to deploy this into production after I introduce certain changes to the logic. So again, this is all around the ability to collaborate between machine and human beings. So you get all the benefits of the machine learning. You don't have to input any of your own rules. You don't have to spend years developing your own code or your own rules. Everything is bubbled up automatically by the machine learning based on your historical knowledge. But you can also go in and actually modify that on your own in the system. And again, this is how human beings in our system, administrators in this case, collaborate together with machine. Example number 2, this is around the testability part of machine learning models. So what you see here is essentially a real-time preview where you can take any learning, any insight that came from the machine learning model, choose a time frame, so you can go back 3 months into the past and say, I had a certain issue 3 months ago. Let's see what kind of insight BigPanda would have generated based on the machine learning, the current machine learning model when we go back in time. And you can do this in real time, so you don't need to wait 3 minutes, 5 minutes, or a few hours or a few days to test this. You can just hit a button. There's a regenerate button right here at the top. You click on that, and essentially you get a real-time preview around what the model would have done based on your historical data. And example number 3, the last example, is around how we verbalize to the end user, to the operator, how we verbalize decisions around correlation. So what you can see on the left, this is an example of an outage where your SQL server, your database cluster had a load issue in your production environment, and many events were detected that were related to that. Instead of just correlating all the events together and telling the operator, well, these events are related now, go ahead and figure out on your own why they're related. The system immediately verbalizes in real time the reason they're related and saying they're all tied to this database cluster and they are all load-related issues. On the right hand, you can see an application issue with my analytics application in my Dublin data center. Again, same thing. Instead of just correlating many events together, and then you have to go ahead as an operator and figure out why these events are related by inspecting each one of them in isolation. BigPanda would automatically bubble up, in this case, a verbalization around why they're related. In this case, all of them are application related in my Dublin data center. So this is another example of, again, how do you create better collaboration between the machine learning model or the AI model and the operator. So to summarize kind of our recommendations based on all that we have seen, I would definitely strongly recommend using machine learning and AI. If it sounded from the challenge slides, like I think, this is not trouble worth getting into, that's not true at all. I actually seen many organizations that have been extremely happy with machine learning and AI. And the way to get there, the reason to get there is essentially if you're trying to achieve three things. If you're trying to introduce more efficiency to your team, if your NOC has been growing 20% every year, year over year, you throw more and more headcount at the problem. You want to stop that and actually start using automation more. This is definitely a good reason to use machine learning and AI. If you are moving into more dynamic infrastructure, right? If you have people, instead of moving from, a weekly deployment to a situation where people are deploying multiple times a day, if you're moving into containers or clouds, definitely a good reason to use machine learning and AI because rules are not going to cut it in these environments. You'll find that rules just don't work in these environments. And lastly, if you're just trying to introduce more efficiency around time to repair or time to any action or assignment for an issue, machine learning can be way more effective or faster than human beings in doing this kind of initial triage and actual remediation of issues. But my 2 other recommendations would be this. One is be very careful in terms of hype. There's a lot of unrealistic expectations out there coming in from everyone, from analysts, vendors, of course, and even some people in actual companies that are telling stories that are just not realistic, just not going to work. And if you hear somebody telling you that you'll deploy their software and within 2 months everything in your organization will be AI driven, this is just not reality, and I have yet to see even one organization that was successful with deploying AI holistically across their company within a matter of months. It's just not possible at the moment. And That's okay, because if you're patient and you're willing to work incrementally, like we discussed, you will get great results that will more than pay for the investment that you're going to make. You just have to take a very realistic and pragmatic approach there. And finally, and this is my last recommendation, is take an open box approach. If a vendor says you don't need open box, machine learning can do this, there's some kind of magical system here that you just trust and it will just work. You don't need the open box elements. Just walk away unless you want to waste a lot of money and a lot of time and be disappointed at the end. So I definitely strongly recommend to use open box whenever you go down the road of machine learning and AI in your IT operations. And with that, let me hand it over back to Colleen.
Thanks, Nancy and Elik. It's now time for our Q&A session. As a reminder, simply type in your question in the box below, and we will get to as many as we can. The first question is, how long does it typically take to train AI ML ops tools before they can start correlating incidents?
Elik, do you want that one?
Yeah.
I think, if you want to just give an example at BigPanda, that's probably helpful.
Sure, Nancy. Yeah. So, I think it's a very good question. If you rely on supervised learning, where human beings train your system, that's valuable information, valuable insight that you can provide to the machine learning model, but it's going to take a very long time, because until you input enough information from your human beings, that can take months. It requires, like I said, immense discipline to get there, and it can take literally months until the system actually gets enough data to provide accurate results. But there's an alternative where you actually teach the system via unsupervised learning, where you essentially look at the data that is flowing through the system and you learn from there. And then normally that learns very quickly, because there's so much data being generated today that you can often even a few hours of data is enough for the system to start generating meaningful and accurate insights. So our customers normally, if they have large data centers with tens of thousands of devices in them, within a day or two they'll find some very good results thanks to machine learning. If there are smaller data centers and they have hundreds of devices, it's still fairly fast. It can take a week or so, maybe 6-7 days. But it's definitely something where you can see the return on investment, very quickly. You don't have to convince people to be patient for months until they see value. So it really depends on the approach you're taking. If it's data-driven, unsupervised learning, very quickly. If it's human-driven and supervised learning, still valuable, but it's going to take normally months until the system really learns from the supervised approach.
Great, thank you. Next question is, we hear about unknown unknowns and known knowns. What does this mean, and how important is this for NOCs in selecting AI ML ops tools?
Yeah, interesting question. Essentially, there are three layers, and the quote, by the way, I think it was Donald Rumsfeld that used it in another context a few years ago, but essentially it refers to three layers of insights that an organization can have. There's the known knowns. This is around things you know that you know. You know that you know exactly the dependency between a certain application to a certain infrastructure component. These are things that you know that you know. Then there are things that the known unknowns. These are things that you don't know, but you know that you don't know. For example, you might have an application where you have no metric around the latency in this application, or maybe you have a certain module in your network that where you don't have any log data. And this is an area where you don't have any insight, you don't have any visibility, but you know that you don't know about its existence. And then there's unknown unknowns, which is the most difficult aspect of IT operations. These are things that you don't know about, and you don't know that you don't know about. So it could be that maybe I have a certain issue where whenever a certain queuing system fills up, I am getting certain outages in some critical applications. And this is a dependency I'm not even aware of. So I constantly get those outages in my application, but I have no idea why they're happening. I have no visibility around the lack of visibility in this case. And machine learning can definitely help with known knowns are very easy, and normally you can handle them using rules-based systems or maps. But the known unknowns and the unknown unknowns are the two things where you really can and need and should leverage machine learning and AI. This is where the system essentially would go through your data and your actions and find out dependencies or certain trends or patterns in the data that you weren't even aware of, and make, for the known unknowns, it can just introduce new visibility to areas where you didn't have visibility, but you knew you didn't have that visibility. And for the unknown unknowns, it will introduce new levels of visibility towards things you didn't even know about, which is even more powerful. So, yeah, good question.
Yeah, I think just in summary real quickly, I just wanted to add, I think the thing that's really important and the reason that you might, the person who asked that question, the reason you might be hearing about that is that, initially there were machine learning AI applications in an IT ops context where the end user had to apply the machine learning only to specific data sets. And the problem with that is you have to know which data set might benefit you by running the machine learning on it, which means you're going to miss a bunch of other stuff that you just are not aware of. So I think it's just something to look for when you're choosing a tool, is whether or not you have to totally control that, or whether the tool itself will be able to identify trends that you might not even be aware of. So I just wanted to add that.
Thank you. All right, we have time for one more question today, and just a reminder, all other questions will be answered via email. So final question for today is, can the model be controlled by parameters like seasonality input or time of day urgency changes?
Sure, good question. The answer is yes. The short answer is yes. The long one is that in general, modern environments are very, like we discussed, very complex and fragmented. And part of the challenge with using more direct approaches like a topology map or a rules-based system is that it's very hard to handle the different kinds of data sets or data points that will help you get to insight. There are literally tens of different things that you can leverage to get to insight. So there could be, like the question says, there could be things related to time of day. It could be related to a specific season. There are things around topology where maybe you see that things coming in from the same server are more likely to be related to things that come in from different parts in your environment. There are often a lot of insight that can be generated just by looking at textual similarity, right? You would look at a certain description of one alert and a description of another alert, and it will say, hey, these are actually fairly similar, enough for me to say they could be related, and this is another important data point. So what we see today is, and as we started building our algorithm over the years, we just realized that just one data point was never enough. Like initially we had 2 or 3 different data points that we would use in our algorithm, and it worked fairly well in some environments or in some systems or in some times, but it was never robust enough. And we realized that the trick here is really to have multiple heuristics, we call them heuristics, multiple data points that the system can leverage to be able to get to insight. So definitely time of day is a very important one. Seasonality is a very important one. Like I said, textual similarity is another. Topology is another. There's also just a kind of relative time frames where you say, things that happen around the same time are more likely to be related than things that happen way apart. There are things that are more domain specific where you can say maybe things in the cloud behave in a specific way, which is very different than how things behave in a virtual private cloud environment. So all these data points are incorporated into the algorithm, and that's what it uses to get to insight.
Thank you so much. That concludes today's webcast. As a reminder, the on-demand replay will be available on BrightTalk soon. On behalf of BigPanda and 451 Research, thank you all for attending, and have a great day.